Hello, this is Team Polk bringing to you our overview and a presentation of our software testing and debugging process for our class software testing. Members were Vlad, Leonard, Walter, and Timothy. Our task was to receive a fault-seeded classroom program that different groups created, and our task was to document any and all bugs found, and our mission was declared successful if our documented bugs outweigh the number of bugs that were documented by the team who created them. So let's go ahead and jump into the so before compilation of a supplied program, it was important for us to scan for malicious code that might cause damage. In order to save the integrity of the closed box testing phase, only code that may do physical harm to the host PC or its OS was altered or removed. So we didn't do many major changes, just things that we knew that would cause fatal errors or segmentation faults or someone's terminal to freeze. Those are the things we altered. Once safely verified, we basically compiled the code to the next computable, and we moved on to the closed box testing process. Now, in this closed box process, it's very important for the user to know what they need to enter into the program. And this was not clear initially. There was only one command given to us, which was help, displayed on the right here, which unfolded a list of 5 commands to go through the program, but it is deeply flawed, which gives us a harder time at really looking at what's under the hood, what's really going on in the program in our closed box test. From this closed box test point, we saw that most of the functions weren't working properly, and a lot of things weren't being saved. For example, we noticed that when we type in the command save, the file that was existing on the hard drive would be overwritten completely. And when we tried to exit the program was unresponsive. So we definitely knew we had to go ahead and continue from this closed box test into the open box to see what was actually wrong, preventing the program from functioning the way that it should. So this adding student name section, this bug, this was more documented for us as a design flaw opposed to an actual bug. We had to make sure that there were steps to ensure the user entry checking had not been implemented, and as this assignment is not to recode the entire program, we decided to just leave the issue unaddressed. So we just went ahead and documented it and moved on with the rest. So in this section, basically, we had done all we could with the closed box test, and we had to move on to looking at the code line by line. All the code for us, we had to comment it out, and basically, it was a process of meticulously looking at each line and examining whether it was a good piece of code or a bad piece of code. There were simple errors that we were able to detect, such as spelling errors and out of bounds errors, but other things that were more logical errors, such as functions not being placed within the right calling scope, took a little bit extra time to find. So after looking at all of the code line by line, we had a couple of initial observations. We noticed that the file IO was used as a class. This is taught by some instructors, but in this implementation, in this scenario, we don't know why it would be beneficial to a class for a program. And that's perhaps it's why the case we considered this a design issue rather than a bug. It's just kind of an overly complicated method of saving data. Now that we had basically documented the code line by line and commented out what was good and what was bad code, it was time for us to determine what code caused what issue. And what we really wanted to look at is the reasoning of why the save function and the retrieving student data functionality wasn't working. And it turned out to be a little bit of syntactical issues, but mostly it was issues concerning um, the file management and the swapping of certain function calls. So we did note that there was not a file given in the initial process of our debugging, um, and that's a design flaw. We know that not as a bug simply because the program won't function properly ever if the file is not given. So you know, most of these issues were cleared up once we actually implemented our own sample files, and that will kind of pour into the rest of the presentation. We'll talk about our unit testing and what we did to kind of automate the testing process. So methodology, basically, we wanted to look at the save function a little bit more because we didn't understand the internals. We didn't understand how it was working, why it was failing. Save function was spitting out the grades in a different order from which it was pulling them in. So to find this error, we needed to isolate where in the process the grades were getting mixed up. To do so, we simply just placed cout statements, basically where we thought the error would occur. And then basically moving those brackets around while checking the output, it allowed us kind of to narrow the range of field where the problem was occurring. It's kind of a variation on unit testing, but print statements has been around for a long time, and it's a good way to find some bugs in the program. We wanted to move back on to some of the things that really stood out more than others were these design issues, and not really we consider them as bugs, but we wanted to consider them as design issues. These are flaws within the code, nevertheless. They may not be important to the coding process or the functionality of the program, but it does put a hampering on your ability to understand what's going on with the code. If the UI is not laid out in a presentable way, that's understandable to debuggers such as ourselves. We were able to, at this point, to flesh out all of our cosmetic design flaws and some internal bugs that are wrong with the program. And once we had overviewed the save and search functionality of the program, we were able to move on to automated testing. Note that before we begin the automated testing, we weren't able to verify that the code met all the requirements for the classroom attendance program. For example, there was a search function that was missing. It wasn't implemented fully. There was a command for modifying a student, but it's not inherently searching for a student in hand by first name, last name, email, or UID. So we wanted to note that as well before we moved on to explaining our automated testing process. And now it was time to move on to our automated stress testing. For our stress testing, we wanted to stress the program by quantity and not by quality. What I mean by that is, this is the part where we do it by the amount of data the program could hold versus the quality of the data the program can actually correctly save to a file. So we simply used a for loop in the beginning, and we wanted to see how many students could we cram into this program until the program finally crashed. And after doing like some binary search, playing around with the numbers, we found that 100,000 students works to creating a file size about 4.1 megabytes. And after a little bit more time, we found that finally our cap was about 1 million students. 1 million students, the program took a long time to add into the database, and the program ended up freezing. So found that the program can handle a good amount of students, but 1 million is kind of reaching that max limit, and probably something in a couple 100,000 is where the program is going to be pushed to its maximum capacity of being able to store all of those students correctly. Now we had some remaining issues. The user entry, as we talked about before, was more of a design flaw, but it was hard for us to tell whether we were entering the correct input or not because no instruction was really given. We were given a small list of commands. We weren't given a list in totality or a full explanation that could have helped us figure out what was considered to be a bug and what wasn't actually a bug. These bugs couldn't really be figured out in totality and would require a further in-depth modification of the code, and we didn't want to compromise the integrity of what was given to us. So these bugs, as mentioned earlier, we didn't find a search function, and the student ID assignment organization was not given to us in a specified format. We're kind of left in the open and in the unknown to wonder as to whether this program can actually function correctly or whether it's a program that's failing. So after our stress testing and looking back at some of the design flaws, some of the uncertainties we had in the code, we wanted to go ahead and take a look at unit testing. We wanted to go ahead and take some of the classes and some of the functions given in this program, and we wanted to modify them in a way that we could perform individual automated testing. So we took a look under the hood again. We modified those functions, the save functions, the modifying functions, to see and to make sure that the code could operate on its own. And we used simulated input, just as we used a simple for loop script for our stress testing to see how many students the program could hold. We used a simple shell script that would basically take a given input per what type of function we're using. For example, the save function, we wanted to pass an input of a student with the name, email, UID, a couple of grades. And we wanted to see that to confirm that the program worked correctly before attempting to test the program as a whole. Now we did have some failures and accomplishments in that, sometimes the program did run as expected to, but once we did our stress test, and we wanted to go ahead and move on to our automated unit testing. And this required a lot of planning and detail. We weren't sure how to go about this first, but we knew that since we were given most of the functions already as separate entities from each other, we only needed to modify a few lines of code in order to make them completely function on their own, so that we could go ahead and pass some automated input into them, and we could basically test expected output versus the actual output we received. And so 3 types of input were given. Sometimes in our shell script, we would use working input, such as a string for a first name or last name. Time, for example, we have valid input for a string. But sometimes we want to pass malicious pieces of code or malicious pieces of input to the program to see how it would function. And we were in hand able to see everything that was under the hood. We were able to see what functioned correctly and what gave us our expected output. And it was a tedious task for us to get this automated testing done. But I believe the important part for us was the ability for us to feed each module, each function, its own malicious or non-malicious input, so we could verify that the expected output matched the output that we were getting from these automated tests. For example, we had one that would just test an integer. We would test if something was an integer. Given the code initially, we didn't have any type of type checking within the program. We didn't find any of that in the program, so it's something we had to add within the automated testing process to see if our expected output was the actual output. And simple tests like this, or simple pieces of code that are written like this, can really help you understand. It really helped us understand what types of code were considered malicious and what type of code were considered non-malicious to the program in hand. And once these unit tests were performed and completed on each and every single module, we just had to advance to the next stage, which were including methods that were dependent on other base functions. This is basically what we're trying to basically put back together what we have broken down into modules. We wanted to take those modules and automate them and test them in a way that they were together once again as a single program. Rather than using a single input, many of these functions require a list of several inputs, which is why the test cases were hard to come up with. We had to make sure that we could give verifiable and good pieces of input in order for us to actually compare our expected results to the actual results.